Welcome to Sundar's lecture. This is lecture number 7, and in this lecture we are going to see the representation of logic function as well as what is min terms, max terms, and then how to create a k-map for different variables. For different variables in sense we will have 2, 3, 4 variables, and how to create the k-maps, right? We will see the beginning of the k-maps, how to simplify the Boolean expressions using Karnaugh map, right? So before that, in the previous class we have stopped this one, right? So we try to uh, solve this problem and then we will go to the next topic, right. Now this is the problem and we need to simplify this, right? So what you do, you don't do this the whole bar, you just keep that whole bar as it is, don't do anything. By De Morgan's theorem, what we can do this one, we can split this one, right? So by the anyhow, maybe you see here a b the whole bar, you keep this also, you don't do anything. See this one, this is a plus ab, sorry, a bar plus ab. I have already told you, right? We know this one, a plus a bar b will be is equal to what, a plus b, right? So this variable here, it is complemented and you have to leave the complemented variable at these two. Same thing is here, right? So what you do here, you put plus and then you just write this a bar plus b. Simply we can write this one and this one can be added. And now what you do, you just split this one by De Morgan's theorem. What you will get, this is a bar plus b bar, right? So this is actually a bar, a dot b the whole bar, and you will get this as the a bar plus b bar and then plus a bar plus b. This is the expression, right? And now you see this one, this is b bar plus b. What is this one? B bar plus, sorry, b plus b bar will be is equal to what? 1, tautology, right? These two are tautology, right? So what you will get, simply you don't need to do anything. B bar plus b can be written as 1 plus a bar plus a, whatever it may be, what you will get, obviously you will get 1. And then what is 1 bar? 1 inverse will be 0. This expression will give you 1 bar. What is 1 bar? What is the inverted term of the 1 bar? It will be 0. That is what we have written here, and that is what you need to prove here, right? Very simple, right? So this is the whole idea. And now you come here, now this problem, what you can do here, you have to prove this as now a. You see here a is common in all the terms. So what you can do, you can take this a commonly outside. What you will get b plus b bar will come, b plus b bar, and then plus b bar c will come, right? This is the equation. It is a simple straightforward answer. What is b plus b bar? It is 1. B plus b bar, it is 1 plus anything it may be. You don't need to go with the other terms, because 1 plus anything will give you what? The same term, a, simply, right? So this is the simplification. And also there is a problem here. What we will do, we will take here, it is anything is common, we have to see the common terms. That is the whole idea. See here, in these two terms, b bar is the common term. See here, in this term, a c bar, right? Maybe I will take this a c bar, and here also it is, sorry, a bar c, and here also it is a bar c. It is a common term. And in these two terms, a and then c, and then here also a and then c, both are common terms. So you take this one, a bar c, you take commonly outside. What you will get? You will get b bar. You will get b bar plus b. You will get this one, and then plus you take AC commonly outside, and what you will get here, you will get again b bar plus b. Simply you will get like this, right? So what you will get here, so here you see this term will become one tautology, and then this term will become 1, that is also tautology. So you will get a bar c, multiplication of 1 you don't need to put, plus ac, and here the common term is c, you take c commonly outside, so it will be a bar plus a, again this is a tautology. So finally you will get c, proved, right? We have proved this problem. See, try to understand. We are just simplifying the Boolean expressions with the uh, laws and postulates and some other basic equations, basic simplification. We are just implementing in this equation, and we are getting the final reduced solution or final simplified Boolean expression. Whatever this whole function will do will be the same, that is equal to C. That is the whole idea. You try to understand how to tell you. Maybe you see here, for example, I will give you a tip. What is the real meaning of these simplification? For example, this is a 3 function, right? 3 variables, A, B, C are there. So you will have A, B, and then C, right? So if it is 3 variable, then obviously you will have 8 number of combinations. So 0, 0, 0, 0, and then here you will have 1, 1, 1, 1, and you see here this is 0, 0, 1, 1, 0, 0, 1, 1, and this will be 0, 1, 0, 1, 0, 1, 0, 1. And if you want to simplify this problem, what you need to do, you have to take a bar is there, b bar is there, and there is no c bar, right? A bar is there, b bar is there, b is there, but there is no c. Here also it is c. So you don't need to go for c bar, right? So you find what is a bar and what is b bar. I am not going to do that. You try to do it by yourself. Right, then what you need to find, you need to find every term separately. You find all these terms. What you do, you take a bar, b bar, and then c. Likewise, what you do, you find all the terms. You find all these terms, and finally, what you do, add all these terms like this, a bar, b bar, c plus this term, a bar, b, c, everything. You just add all the terms, and then you write the expression. Whatever you are writing as this answer, it will be c. This will come to this. That is the whole idea. You will have 0, 1, 0, 1, 0, 1, 0, 1, 0, 1 answers. That is why we are saying, for all this expression, we can simply put this as c. Try to understand. You do this by yourself. It is a very simple thing. You just find these things. A bar, b bar, you will get it down, and then a bar, b bar, c. Multiply the 3, and then you put here. Likewise, all the other terms you put here, and then finally add all the terms and get the values. And if you see the particular value, it will be equal to c. It will be equal to c. Right? That is the whole idea. Right? So now, what we will do, we will go for representation of logic functions. So what is representation of logic functions? There are two different terms are there, right? So for example, we generally write a bar b c plus a b plus a c bar plus a b bar, like that we will write the expressions, right? So, or in other hand, we can also write the expression like this: a plus b, then multiplication of a bar plus c bar, multiplication of a bar plus b bar, like this. We can represent the Boolean logic functions in two ways. One is like this, one is like this. And there comes the different types of the Boolean expression. One is sum of product. Sum of product. Right? That is we generally call SOP. And one is product of sum. Product of sum, that is POS. So there are two different forms of Boolean expression. One is sum of product, one is product of sum, right? So these functions are sum of product, and these functions are product of sum. Why? You see here, we have products, we have product. This is actually product, right? Dot functions are called, otherwise called as product, and that will be splitted by sums. That will be splitted by sums. That is why we are calling it as sum of products. Sum of products. And likewise, this is product of sum. You see here, this has the sum functions plus, right? Everywhere you go, you have sum functions, and that was splitted by product. So that is why this is called as product of sum. This is actually product, right? So product of sum. So these are all two different functions we have, right? So what we need to do now, one thing I will say you, see here, you take an example, we have as I equation, a Boolean expression, like which has the function of a comma b comma c. See here, why I am writing this one. I am writing this to you for the first time. See here, this is actually a function of ABC. This is actually a function of ABC, right? And if you have any two variables, then they will represent it as function of AB. If you have four variables, then they will represent this as A, B, C, D. So, for example, you have an expression like this, like AB plus AC plus A bar BC plus A C bar. For example, you have a function like this, Boolean expression maybe, and you see here, this has three different variables, but you see here, this term this term has only two, missing C here, no C is here, as well as you see this one, only AC is here, you don't have B here, and you have all three terms here. So this one is not a issue, this one it is correct, and you see here this one also, you don't have B, again you don't have B, right? So what is the problem here? This particular Boolean expression is not in canonical form, or we generally call it as standard forms, right? So standard or canonical forms. This is very important for learning the Karnaugh map. First you have to get the equation in a canonical form. If you don't have canonical form, then you have to convert the Boolean expression into canonical form. So that is why we generally call these functions are not in the canonical form or in standard form. This is in a general form, right? What we need to do now, we have to get this function, get this Boolean expression into canonical form. That is the whole idea. So what we will do now, the title will be conversion of first we will take SOP, sum of product to canonical form, right? So generally I will take straight away an example. For example, you have convert the Boolean expression to canonical form. Right? That is the question. We will take f of a comma b comma c, and we will take some expression a b bar plus a c bar plus b c plus b c bar plus a bar b. Right? This is the expression, and maybe you take one as the same. And now this is the expression, right? So what you need to do, you have to convert this particular function to canonical form, because You see here, you don't have any C here, B here, and then A you don't have A here, and also you don't have C here. So you have to convert this into canonical form. So for that, what you do, you just see the distributive law. Distributive law. What is distributive law? That is very important. Distributive law. So we will go there. See here. This is the distributive law we have seen. This one, this whole function, right? So maybe I will take this one. This is first law. I will copy this and then I will paste it. So this is the distributive law, right? So now what you do here, you just take this function, a b bar is there, and if what is the other term you don't have here, c, right? So what you do, you just multiply c plus c bar. What is this one? What is this one? Actually, this is stat logic, and if you simplify this, you will get 1 here. So I can multiply 1, no problem, right? So that is the whole idea. Plus, you put plus here, and then you don't have b here. So what you do, you put a c bar. If you don't have b, so you take b plus b bar. B plus b bar. Again, it is stat logic, so I can cancel it out. And then plus bc is there, no problem. And you don't have a here, so you put a plus a bar, simply. And then plus again here, b c bar we have, and we don't have a, right? So a plus a bar, likewise. And you take this expression plus this expression, you don't have c, so you take this as a bar b plus c bar, and plus you just keep this one as it is. You don't need to do anything with this because it has already in the canonical form. Alright, all the three terms are there. So now what you can write here, you can multiply AB plus AC. That is what we have done here. You do the same thing. So this is A bar B, C is one term, and sorry, A B bar C is one term. Put plus A B bar, C bar is the other term. Simply, and then put plus a c bar is there. So you see here a c bar is there, so I can write a b c bar, right? So this is a b c bar plus a b bar c bar, that is the other term. And then from here you can go like a b c, and then you can write this as a bar b c, and then put plus, you write this term a b c bar, a b c bar, and then a bar b c bar plus a bar b c bar plus this term, you come here, this will be a bar b c plus a bar b c bar plus a b bar c is the term. Right, now whether this is the final expression, no, this is not the final expression. Try to understand one thing, you have to compare. See here, you have this term, that is a b bar c. See here, you have a b bar c here, as well as a b bar c is here also, same term. And we have already seen what is a plus a. What is a plus a? It is a. We have already seen, this is one law, right? This is one law. So you don't need to write two times. It is, you can write one time. So this term a bar, a b bar c can be written as one time. You can leave this one now. You can leave this one. As well as you see here, any a b bar c is there. A b bar c, see here. See here. This is also here. Maybe I will take a different color so that you can understand. So this one is here. This one is here. So what you can write? One term. You can neglect this one. So this will be a b bar c bar, and then plus a b c bar, a b c bar, a b c bar. Here, yes, it is there. See here, this one and then this one. You neglect this. Write it as a b c bar. You have already neglected this, so you don't need to see this one. A b c is here. Right, ABC, there is no ABC, right? So you straight away write this ABC. Straight away write this ABC. And A bar BC for here. A bar BC is here as well as it is here. So you can neglect this one, neglect this. So, so if you neglect this one, so you can write this one. So this is A bar BC, right? We have written, and then you see here again. Maybe I will take this one. See this one. This is one term, that is A bar BC bar, and also you have here also A bar BC bar. So you neglect this one. So this one I can write it down. So this will be A bar B C bar. So you try to understand, this is the final canonical form. This is the final canonical form, right? For this function, for this Boolean expression, this is the final canonical form, and you can see here all three terms are available in every, we can say this as literals. Every single term is a literal. So every single expression in this expression, every single terms have all the three variables. So this is the canonical form, right? So now what we will do, this is the whole idea, and then we will go for the other conversion. Second one, conversion of product of sum. Now product of sum, that is POS, to canonical form. Canonical form. So I will write down any one expression now. Right. So you see here, I have taken a POS function, and we need to convert this into the canonical form. And we know this distributive law. A plus BC can be written as what? A plus B dot A plus C. That is the whole idea. That is the distributive law. We have already seen this one, right? So now you see, you have a function. You have a function of ABC function. It has different terms, and every term don't have all the three variables. So what you do for POS, to the beginners, because you people are beginners, what I will do, I will take separately every terms. For example, here I will take maybe in a different color. See, I will take A plus B separately, and I will write it down here. So for this, what you do, you can write like A plus B, and then you put plus here, What is the missing term here? It is C, right? So what you do, now you just put it as C dot C bar. C dot C bar. What is this one? C dot C bar. Fallacy. Fallacy becomes 0 always, right? So plus 0 will give you what? No problem. It is 0. So if you further simplify this one, if you further simplify this one, using this term, it is A plus B plus C. You see here, A plus B, right? And then A plus C. And you see here, you take it as the single term, and you can write like this one, right? So what you can write here, it is A plus B plus C, that is the first term, dot multiplication, right? This is actual multiplication. And then you can write it as A plus B plus C bar. That is the whole idea. Huh? Use this one. You see this one, right? A plus B, first term, dot A plus C. Same wise, A plus B plus C, dot A plus B plus C bar. Actually, here it is a dot, right? So you try to understand. So this is the first term. Simply, right? Go for the other term, second term. I will go fast now. B bar plus C. So here, what you do, this B bar plus C, it is same. But what you need to do here, what is the term you have to add here? It is A dot A bar, simply, because this will be 0 now, right? So what you will have, now I will write A first. So this will be A plus first term B bar plus C. That is the first term, and the second term will be A bar plus B bar plus C. That is the second term. That's all. I will go for the other term, A plus C bar, and the missing term here, it is A plus C bar is there. Missing term is B plus B dot B bar. B dot B bar is the missing term. B is the missing term, so I am writing like this. So this will be A plus B plus C bar, this whole term, dot A plus B bar plus C bar. This is the other term. So finally, I can write all these terms now. All the because this is a full term, no problem. So I will write down it is equal to you write every terms now. A plus B plus C, that is the first term, and then A plus B plus C bar, that is the second term. This one, this is dot A plus B bar plus C dot A bar plus B bar plus C dot this term A plus B plus C bar dot that is there A plus B bar plus C bar and then dot, and you can write this term. This is the full term. See, this is full term. Try to understand. I am not writing this one here. This is a full term. You have to write it down here. A plus B bar plus C. Now, what you do straight away, you know this one. A dot A will be also what? A. So, if you see any two common terms, then you have to cancel one term. See here, A plus B plus C. Is there any other terms? A plus B plus C, everything is bar, everything. So, this one is valid function straight away. And A plus B plus C bar, A plus B plus C bar, A plus B plus C bar. See here, this is A plus B plus C bar, this is also A plus B plus C bar. So, you neglect this term. Straight up, you have to write any one term, that's all. Next one, A plus B bar plus C. A plus B bar plus C. See here, it is A plus, so you don't need to write this. And this one you have to write, this one you have to write. And you have to see here, A bar plus B bar plus C, you have a different function. So this is also you have to write, so this is also you have to write. So finally, this term can be written as A plus B plus C and then dot A plus B plus C bar and then dot A plus B bar plus C and then dot, this will be A bar plus B bar plus C and then the finally you'll have this term. So this is the final canonical form for this Boolean function, that is product of some expression. This is the final canonical one. You can see here all three terms will be there, three terms will be there, three terms will be. So what I want to tell you now, this is the whole idea, this is the general procedure. This is how you need to convert by using the distributive law. But what you can do, you can go for the shortcut method. So I will tell you the shortcut method in a quick time. So I will take SOP function first. I will take SOP function. See here, if I have a function like this, for example, f of a comma b comma c has like a b bar plus b bar c plus a b bar c. For example, you have a function like this and you need to convert this into canonical form. What you do, you straight away write what is the missing term here? What is the missing term? C, right? So you write A, B bar, C first term plus same term A, B bar, C bar. Simply. And then you come here, put plus, that's all. You write two different terms. You missing term C and then with this you put C bar. And then you come here, what is the missing term? A is the missing term, right? So you put A, you write this one, B bar C and then plus again A bar. You have put A here, put A bar here. A bar, same term. B bar, C. This is whole term. You can directly write this term. No problem. And what is the term you need to cancel out? See this one. A, B bar, C is here and you have here. So you don't need to put here. And also you see here, this A, B bar, C is also here. So again this will be, see, A plus A will be what? Again it will be A. So you can cancel this one. And you can write this one, this one, this one. So this will be A, B bar, C plus A, B bar, C bar plus A bar, B, C. This is the final answer. This is the final answer. You don't need to put plus C, C bar. It will take some time, but this is the shortcut method of converting the SOPs, right? So this one also follows the POS. So you try to do that and I will tell you in the next class, right? So what are all the topics we have seen in this class? We have started with representation of logic functions, and in representation of logic functions we have two different types. One is sum of product and the other one is the product of sum, right? So for example, if you have any functions like this, if this function is ABC, but we have a function like this, right? So here we are missing C, B, and then here also we are missing B, and this is not in the standard form, right? So if you want to convert this into standard form, that means conversion of sum of products to the canonical form or standard form, right? So we have used distributive law to find the canonical form, as well as we have gone for the product of sum to the canonical form, and also we have used the distributive law again, right? So we have converted the product of sum into canonical form, and how to convert that one, that is the procedure we have seen. And then also we have seen the shortcut method, right? We will see in the next class. Thank you.